Welcome to NGIT Math Podcast today. My name is Tao Ling, and I will try to explain to you how to simplify a complex expression, complex fraction. Now, let's look at an example. You want to simplify 1 over x squared minus 2x. Okay? So now we see that this big complex expression consists of two parts. One is its numerator and also its denominator. Okay? So, in order to do this, first of all, we have to treat both the numerator and denominator separately. Well, the numerator is a addition of two rational expressions, so we should simplify that first. Okay, so in order to add that 1/2 plus 1 over x, we have to change them into the two fractions with the same denominator. So we could change them into base 2x, so it becomes x over 2x plus 2 over 2x. Now we can add the numerators, which would equal to 2x and x plus 2, right? And this whole thing divides by the second expression, which is x squared minus 4, 2x. Okay, so this is we converted the initial numerator into this form, which is not a sum of two rational expressions anymore. It becomes one rational expression. And since now we have one rational expressions divide by another rational expressions, we can use the methods where one rational expression divided by another rational expression is the same as one rational expression multiplied by the inverse of another rational expression. Okay, so it's x plus 2, 2x divided by multiplied by the inverse of that rational expression. Now we just have to simplify it. Well, 2x and 2x cancels out, and this becomes x plus 2, x squared minus 4. And now we see that x squared minus 4 is not completely factored, so we should factor that. It becomes x plus 2, x squared minus 4 become x plus 2, and x minus 2. And when we see that we can cancel out x plus 2. So the final answer will be 1 over x plus x minus 2. Okay? That's the final answer. So, now if we review that, is to simplify a complex fraction is you have to simplify both, treat numerator and denominator individually, making them both into just one rational expressions. So in this case, the numerator is actually two rational expressions because it's 1/2 plus another rational expression 1 over x. We have to convert it into one rational expressions. So when you have one rational expressions divided by another rational expressions, you can actually make them into a product of two rational expressions, and then you can cancel them out and factor them, and you'll get your answer. Okay, so let's try another problem. X over 2x minus 7, 3 minus a half. Okay, so now we have to treat both the numerator and denominator separately, because the denominator is actually two rational expressions. Well, actually more than that. The 7 over 3 minus a half is actually a even more complex rational expressions. So we have to evaluate the denominators by itself first. So this would equal to x, 2x minus 7. We can actually calculate what's 3 minus a half. Well, it's 5 over 2, right? So now we know that 7 divided by a fraction is the same as 7 multiplied by the inverse of that fraction. So it's 7 multiplied by 2 over 5, which gives us x, 2x minus 14 over 5. Okay. Now, well, we're getting closer because we actually changed this into just 14 over 5, one expression. Now we just have to change 2x minus 14 over 5 into a single rational expression. So x. In order to do that, we have to convert both of them into base 5. So this should be 10x, because 10x divided by 5x should give you 2x minus 5, 14. So this would equal to x, 5, 10x minus 14. And this is good because now we have one rational expression divided by another rational expression. And that's what we want to see. So we know that when you divide one rational expression by the other, it's the same as x multiplied by the inverse of that rational expression, 5, 10x minus 14. Right? The result is 5x, 10x minus 14. Okay? So you can still factor them because 10 and 14 has a 2 can be factored out. So 5x minus 7, 5x. And now it's completely factored. Okay? So if we review the process, it's that we have to treat both the numerator and the denominator separately, converting them into one rational expressions. Okay, then we can proceed. Alright, so that's it for today, and thank you for watching. Good luck and enjoy your study.